Hey everyone, welcome to the Scatter Plots Guide and Notes. To get started, we're going to start with some definitions. We are just going to define the first two vocabulary terms, and then we will go back to the rest of the terms after we complete the notes. Bivariate data is data for two variables. Quantitative data are variables that can be measured numerically, for example, age, height, weight, speed, distance. On to the next page, it says, a scatter plot is a mathematical diagram displaying values for two data sets. Scatter plots show how much one variable is affected by the other. This is a scatter plot that shows minutes spent studying for assessment and the percent of the assessment. So the two variables are minutes studying and percent on test. When it says variables, that means the two things that are being compared to each other. After creating a scatter plot, you need to analyze your graph to understand if there is a correlation between the data. When we say the word correlation, we mean a relationship between the data. One good thing to notice is if there are any outliers. An outlier is a data point that is distant from the other data points. Are there any outliers in the scatter plot above? So we're looking for a point that is way different than the rest of the others. And I noticed this one right here. It does not fall in the group of the others. Yes, there are outliers on the scatter plot above. Explain your reasoning. This point right here, which looks to be about 115, is way different from the rest of the points. Circle any outliers that you see and label the point outlier. So let's go back up and circle that point and label it. Outliers can skew or have an extreme effect on the data. Another good thing to look for are clusters. Clusters would be a group of data points. Are there any clusters in the scatter plot above? Let's go up here, and I notice this right here. That is a group of points that are close together. So yes, there is a cluster on the scatter plot above. Circle any clusters you see and label the points cluster. Circled it already, we're going to label it cluster. Looking for patterns in the data points is also important. Do you notice any patterns in the data points on the previous page? So if I'm looking at these points right here, besides this outlier, I can kind of notice that the points are going in an upward direction. One important pattern to notice is if the data points are linear, meaning the points tend to move in a line. Let's look at some examples of linear data points. How are the scatter plots different? They go in different directions. So this one's going up and this one is going down. Also, I noticed that this one is more of a straight line where this one's a little bit more spread out. How are the scatter plots the same? They both are generally moving in a linear pattern. Notice that if you were to connect the dots on the first scatter plot, you would draw a line. If you were to connect the dots on the second scatter plot, you would not draw a line. However, the general trend of the data points are in a line, so we can say that the second scatter plot is also linear. Also, linear scatter plots can increase, which means they go up from left to right. They can also decrease, which means they go down from left to right. So going back up to these scatter plots, I'm reading a scatter plot from left to right. So this one would be going up, increasing, and this one would be going down, decreasing. If a linear scatter plot increases, we say there is a positive correlation or association. If a linear scatter plot decreases, we say there is a negative correlation or association. A positive correlation says that as one variable increases, the other variable also increases. Or, as one variable decreases, the other variable would also decrease. So they do the same thing, either increase together or decrease together. A negative correlation says that as one variable increases, the other variable decreases. So they would be moving in opposite directions. Let's look at some examples. So these are my two variables. I want to compare the length of foot and height. Do I think that would be a positive correlation or a negative correlation? If my length of foot increases, then my height most generally would also increase. So that's going to be a positive correlation. we're comparing the age and the weight of your school backpack. So as your age increases, we expect the weight of your school backpack to also increase because you probably have more homework. Percentage on a final test and the number of times class was missed. So as my percentage on a final test increases, people probably miss class less times. Now this is a general statement. It's not always going to be true, but just in general, you'll probably score higher on the final test if you miss class less. So since they're going opposite directions, that's a negative correlation. Temperature outside and the cost to heat a home. As the temperature outside increases, the cost to heat the home will decrease. So those are opposite. That's a negative correlation. As the inches of rain increases, the depth of a lake will also increase because there'll be more rain in the lake. That's the same direction, so that will be positive. Speed and the time to reach a destination. As my speed increases, the time to get there will be going down, will decrease. So that's a negative correlation. Now it wants me to make up my own, so I need to think of a positive correlation and a negative correlation. Let's do, for positive, what if I did temperature and the number of people at the water park? Generally speaking, as the temperature increases, the number of people at a water park will also increase. And we can do a similar one for negative. As the temperature increases, the number of people at the ski resort will decrease. So as the temperature increases, the number of people at the ski resort will likely decrease because there will be no snow to ski with. That would be a negative correlation. If two variables have no relationship, we say there is no or zero correlation. For example, your height and how many inches of rain in a year. There's probably no relationship there. Let's think about the height of a tree and the number of cars on a road. As the height of a tree increases, the number of cars on a road could increase, it could decrease. The height of a tree does not affect the number of cars on a road, so we will say there's zero correlation. The age and the inches of snow in December. So as your age increases, the inches of snow in December, that will not be affected. So that will be a zero correlation. Now I need to come up with my own example for a zero correlation. You could do a person's shoe size and their math test score. They are not related. One will not affect the other. Identify the following relationships as a positive correlation, negative correlation, or no correlation. Create your own examples of correlations. So as time spent running goes up, calories burnt will also go up. So that's going to be a positive correlation because they are moving in the same direction. Amount you eat and level of hunger. As the amount you eat increases, your level of hunger will decrease. They are going in the opposite direction, so that is a negative correlation. Members of your family and money spent on groceries. As the members of your family increase, that means that like the number of members of your family, the money spent on groceries will also likely increase. So same direction is a positive correlation. Now you need to think of an example of a positive correlation. How about height and weight? Generally speaking, as your height increases, so does your weight. They will move in the same direction, therefore that's a positive correlation. We need two variables that will move in the opposite direction. How about as practice time increases, the number of mistakes generally decreases. So practice time and number of mistakes move in opposite directions. And a zero correlation, two variables that do not affect each other. How about a person's shoe size and the number of pets they own? Let's look more at what correlations look like on scatter plots. Think of drawing a line that is as close to all the points as possible. Look at a scatter plot A. Draw a line that is between the points as much as possible. Okay, so we're going to draw a line that goes through the points as much as possible. This line is called the line of best fit. Is the slope of the line you drew on scatter plot A a positive or negative? So going down here, this line right here, it moves in the upward direction. That means that is a positive slope. This means there is a positive correlation, which means As one variable increases, the other variable also increases. Now draw a line of best fit, or a line that is as close to the data points as possible on scatter plot B. So let's go down to this scatter plot right here. We're going to draw a line that goes through about the middle of those points. You're just kind of drawing it as close to the points as possible. Is the slope of the line positive or negative? And it's going down, so that will be negative. This means there is a negative correlation, which means as one variable increases, the other variable decreases. Now let's look at scatter plot C. Notice that the points do not move in a general direction. They're just kind of scattered here. Therefore, you will not be able to draw a line of best fit. Scatter plot C has zero correlation, which means the scatter plot does not show that when a variable affects the other variable. Scatter plots can also have a positive or negative non-linear correlation. Label the scatter plots below as positive nonlinear correlation and negative nonlinear correlation. And it's the same idea. If the scatter plot tends to be going up, it'll be a positive correlation. And see how they don't really go up in a line, but more of like a parabola? That's going to be a positive nonlinear correlation. And this one over here, the points are going down, so it's going to be negative. But notice they don't really go down in a straight line. It kind of curves. So that's going to be a negative nonlinear correlation. Scatter plots can have a strong or weak correlation. The strength of the correlation depends on how close the points are to the line of best fit. If the majority of the points are close to the line of the best fit, the correlation is strong. If the majority of the points are further away from the line of best fit, the correlation is weak. Let's look at the examples below. Draw a line of best fit on both of the scatter plots. Let's draw a line of best fit that's close to the middle of the points for scatter plot E. If I draw one for F, it's going to look about like that. Notice that both scatter plots have a linear correlation, meaning they are going up in a line. However, scatter plot E is a strong correlation because the points are close to the line. Scatter plot F is a weak correlation because the points are further from the line. Label the following scatter plots using the terms listed below. This first scatter plot doesn't seem to have any association. The points are just scattered without a direction. That will be a zero correlation. The scatter plot in the middle, the points tend to be going up in a linear fashion, but the points are further away from the line. So that is weak, positive, and linear. This scatter plot right here, the points tend to be going down in a linear fashion, and the points are close to the line. So this will be a strong, negative, and linear. The scatter plot right here, again, the points tend to be going down in a linear fashion, but they are further away from the line. So that is weak, negative, and linear. This scatter plot right here, the points tend to be going up, but appears to be in a non-linear fashion. So we're going to say positive and non-linear. This last one right here, if I draw a line, the points tend to be going up, so positive in a line, linear, and they are close to the line. So that's going to be strong. So strong, positive, and linear. Scatter plots can be used to make predictions. We will look at linear associations and use the lines of best fit to predict. First, we need to find the equation of our line of best fit. Look at the scatter plot below. Remember, the line of best fit is the line that best represents the trend of the data. Draw a line of best fit on the scatter plot below. Now, in real life, you can use calculator or programs on the computer that do this exactly, but we are just going to be estimating. So we're going to draw a line of best fit that is here close to the data. Maybe it would look something like that. Estimate the y-intercept of the line you drew. So if I jump back down here, my y-intercept looks to be about 17. Is the slope of the line positive or negative? The line that I drew goes up, so that would be positive. To determine the slope of the line of best fit, we need 2 data points on the line. 2 data points on or close to the line of best fit that you drew are, so let's go down here. I need to get 2 points that are on the line. Again, we're going to be estimating just a little, but if I have 2, that looks to be about 31. So we'll say 2 and 31. And then another line of best fit, let's say if I go to 4 and it looks to be about maybe 48. So we'll say 4 and 48. Remember, to calculate the slope of a line, you need to calculate the change of y over the change of x. Calculate the slope of your line using data points. So we have 48 minus 31, and that will be 4 minus 2. So 48 minus 31 is 17, and 4 minus 2 is 2. If I divide that, I get about 8.5. If you had different estimates for your points, your number is not going to be exactly 8.5. And that's okay for what we're doing. Like I said, there are programs that can figure out the points exactly. We're just understanding what is going on here. Since you have the y-intercept and the slope of the line, you can write an equation of your line of best fit in slope-intercept form. The equation of your line of best fit, well, mine will be y equals, my slope I estimated was 8.5, so 8.5x plus my y-intercept was 17. So it should be about 8.5x plus 17. That is the equation for this line of best fit that I drew. I didn't talk about what this scatter plot is talking about, but it's talking about the number of assignments completed and the percent on an assessment. And so we're trying to see if there's a correlation there, and we're using our data to make predictions. First, let's analyze the meaning of the slope. I'm going to write down my equation up here since it's on my last page. We'll just write it here so I can refer to it. So it was y equals 8.5x plus 17. First, let's analyze the meaning of the slope. Write your slope for your line of best fit, including the units. So my slope is 8.5. Now remember, it's y over x. That's how you figure out slope. The change of y over the change of x. So my units for my y is going to be percent per assignments. So it's 8.5% per assignment. Those are going to be my units. This means that a student increases about 8.5% on their assessment for each assignment completed. Your equation for the line of best fit was y equals 8.5x plus 17. A student completed 4 assignments. Use your line of best fit to estimate their percent on an assessment. So remember, assignments is my x, so I need to substitute 4 in for x, and I will get my y, which would be the percent on their assessment. I substitute in 4, 8.5 times 4 plus 17, and that simplifies to 51. So they will get about 51% if they complete 4 assignments. Now a student completed 8 assignments. Let's use the same thing to estimate the percent on an assessment. Substituting in 8.5 times 8 plus 17 gives me 85%. We are estimating that a student will receive 85% on their assessment if they complete 8 assignments. A student received a 35% on the assessment. Use your line of best fit to estimate how many assignments they completed. So it's giving me my y, 35% on the assessment. So we're going to substitute in 35 for y and then solve for x. I have substituted 35 in for y. Now solving for x, I will minus 17 from each side. And that gives me 18 equals 8.5x. If I divide both sides by 8.5, x is about 2.1. Well, you can't complete 2.1 assignments, so we will estimate about 2 assignments if they received a 35% on the assessment. Look at the scatter plot below. What are the 2 variables? The 2 variables are the resting heart rate and the hours of exercise per week. Draw a line of best fit for the data. So we're going to draw a line that's as close to the points as possible. Estimate the y-intercept. So if I look down here, it looks like my y-intercept is about 80. Is the slope of the line positive or negative? Well, my line is going down, so that's going to be a negative slope. What are 2 data points you can use to calculate the slope of the line? I'm going to use my y-intercept as one of the points, so we'll say 0, 80. And then we need another data point. So we'll do about 2 and 72. Calculate the slope of the line. We will do change of y, so 80 minus 72 over change of x, 0 minus 2. 80 minus 72 is 8, and 0 minus 2 is a negative 2. So my slope is about a negative 4. Explain the meaning of the slope in terms of the scatter plot. And it's always helpful to think of my units when I'm thinking of my slope. So my slope is negative 4, and my units of y, right here it says BPM, that means beats per minute. So we'll say negative 4 beats per units here is hours. So negative 4 beats per hour, which means your resting heart rate will decrease about 4 beats per minute for every hour of exercise per week. Write your line of best fit. So my line is y equals slope, which is negative 4x, plus my y-intercept, which is 80. So my line is about negative 4x plus 80. A teen exercises for 2 hours a week. Use your line of best fit to estimate their resting heart rate. We will substitute in 2 in for our x, because exercise is our x variable. After substituting, I will simplify. Negative 4 times 2 is negative 8, plus 80 is going to be 72. So we can estimate that the resting heart rate will be about 72. Practice. Draw a line of best fit on the scatter plot below. Estimate the equation of the line of best fit. My y-intercept looks to be about 40. Slope of the line of best fit, so I knew 2 points. I will use my y-intercept as one of the data points. So that would be 0, 40. And then another data point, let's use about 545. So change of y, so 45 minus 40 over 5 minus 0. That reduces to 5 over 5, which is about 1. So my slope is 1. Explain the slope in terms of the scatter plot. I'm talking about income, so my unit's going to be dollars, thousands of dollars. And my units on my x is going to be years, so thousands of dollars per year. So the increment will increase about $1,000 for every year of experience. The line of the best fit, so y equals my slope, which is 1. I don't need to write 1x, I'll just write x, plus my y-intercept, which is 40. So y equals x plus 40. Use your line of best fit to predict how much money you can expect to make after 45 years of experience. So years of experience is my x, so I'm going to substitute 45 in for x and simplify. And that's about 90. So I expect to make about $90,000 for 45 years of experience. Use your line of best fit to predict how many years of experience you need to make $110,000. 110 is my y. Now remember, that's in thousands of dollars, so I'm not going to write 110,000. I'm just going to write 110. So 110 equals x plus 40, minus 40 from each side, and I get x is about 70. So I expect to make about $110,000 for 70 years of experience. Let's practice constructing scatter plots. The axes are below, and we will use the variables age of panda and weight of panda. The independent variable will always be on the x-axis. So the dependent variable will depend on the independent variable. So the weight is going to depend on the age. The dependent variable will be on the y-axis. Our independent variable is going to be our age in months. And our dependent variable is going to be the weight in pounds. Label the axes below. Determine the scale of your axes by determining the minimum and the maximum of each variable. The minimum of the age is 1. The maximum of the age is 12. Since the range is only 12 numbers, you can go by ones. The minimum of the weight right here is 2. The maximum of the weight is 55. The range is, so 255 is going to be 53. Going by ones would be too tedious, but you could go by tens. 10 seems to be a good variable to go by. If I went by 30 or 40, it probably wouldn't be enough. So I'm going to go by tens. Draw and label the scale for both axes. I have drawn and labeled my scale. Graph the data. Okay, so we're going to graph this data right here. So starting with 1, 2. So 1, 2 is going to be about right here. 2, 8. We'll just go through and graph it as best as you can. Your scatter plot should look similar to this once the points are graphed. Are there any clusters? So are there any groups of points that are really close together? No, I would say there are no clusters. are there any outliers, or are there any data points that are way different from the rest? And I would say no, there are no outliers. Describe the association. So we're looking for, is it positive or negative? And we're going to say positive. Are the points close to the line or far away? I would say they're close, so that's strong. And I would say linear. So we're going to say positive, strong, linear association. Estimate and draw the line of best fit for your scatter plot you created. Your line should look out like that. The y-intercept, we're going to say that y-intercept is 0. And the slope. Now remember, we need 2 data points, not 2 data points from my scatter plot, but 2 data points from the lines of best fit. So we're going to use 0, 0 as one of them. And then let's use 420. Looks like it's about a point on the line. So 420. So 0, 0, 420. And let's do the change of y over change of x. So 20 minus 0 over 4 minus 0. That's going to be 20 over 4, which reduces to 5. So my slope is about 5. So the equation for your line of best fit is y equals mx, so slope 5x plus 0. So we'll just say y equals 5x. Use your equation to estimate the weight of a panda at 13 months. So 13 months, that's going to be my x. So we will say y equals 5 times 13. 5 times 13 equals 65 pounds. Practice. Construct a scatter plot for the following data. Remember to label the axis and draw the scale. Okay, so let's start with labeling my axes. I have the age of a student versus the weight of the backpack. So the weight of the backpack is going to depend on the age of the student. So age is going to be my independent variable and be on the bottom. And weight in pounds of the backpack is my dependent variable, and that will go on my y-axis. Looking at my scale, my years is going from 5 to 18. I could do 1 tick marks. I'm going to do 2 though. I'm going to have every tick mark be 2 years. And my minimum and maximum of weight in pounds, so I have 1, it looks like my max is 34, so 1 to 34. I don't want to go by 1s. Going by 10s might not be enough. Let's go by 5s. I have my axes labeled, and now let's plot the points. I have all my data points graphed. Now let's answer the questions. It asks me, which point would you consider an outlier? I would consider this point right here an outlier because it's not near these points right here. Remember that an outlier can skew. Skew means kind of like extremely affect the data. Therefore, draw a line of best fit while ignoring the outlier. The y-intercept of the line of best fit is, let's go here and look, it's going to be negative. So it's going to be about a negative 10. The slope of the line of best fit, so let's use 2 points. Let's use 0, negative 10, and let's use the point 1420. That looks to be about on the line. So we have 0, negative 10, and 1420. 20 minus a negative 10 over 14 minus 0. 20 minus a negative 10 is 30 over 14. 30 divided by 14 is about 2.1. The equation for your line of best fit. So y equals mx, or slope. So 2.1x plus b, so that's going to be minus 10. Use your line to estimate the weight of a backpack of a 9-year-old. So let's substitute in 9. So 2.1 times 9 minus 10. And that looks to be about 8.9. So I can estimate the backpack of a 9-year-old to be about 8.9 pounds. Jumping back to the first page of notes to finish up these definitions. A scatter plot is a mathematical diagram displaying values for 2 data sets. An outlier is a data point that is distant from other data points. Cluster is grouped data points. Line of best fit is a straight line that best represents the data on a scatter plot. And correlation or association is a way to describe strength and direction of the relationship between 2 variables. Okay, everybody, that's it for today. Thank you.